Hello students, welcome to the next lecture on the differential equation. Today we will discuss about what is the Cauchy-Euler equations and how you can find its solution. What is the objective of this lecture is we will try to discuss these four examples. All of you can see that there are of the different kinds, and the major thing is that if you look about this Cauchy equation, that is if it is x square, then it must be present in corresponding to the y double dash. You can see that here this is the equation which is of the linear, this is r here. So how you can solve these problems are there, we will see in this couple of minutes are. So what is the objective is that you have to firstly transform this equation, that is this is the my Cauchy-Euler equation, that is here plus x y dash plus y is there, or you can say if it is x cube then it's a y triple dash plus x square y double dash plus x y dash plus y is 0, or in general if it is y xn then it must be the nth derivative of this and so on. So our target is to firstly transform this is the coefficients are not my constant, so we will transform this into the constant coefficients. How you can transform them? We will use this transformation. Which transformation is beneficial for that? I can use this transformation as x is e raised to power z. Once you will use this transformation, then this the variable coefficient is transformed into the constant coefficient, and then we will try to find this as a complementary solutions, that is I can take as a m square and then so on of this auxiliary equations. Myself, Dr. Garg, working in the School of Mathematics, Thapar Institute, India. You can follow this link for finding these various videos. Remember that the general form of the Cauchy-Euler equation is if it is xn, then it's nth derivative. If it is xn minus 1, it's nth minus 1 derivatives and so on. However, this is also called as the Zender equation. Whenever there is instead of the x, it's a linear ax plus b. Again, the degree must be the same. If it is n, this is nth and so on. Where ai's are my constant values, it must be the constant values, and r is a function of the x only. Now, whenever there is a Cauchy-Euler equation of this equation number 1 are there, how you can solve them? We will take as x is z, e raised to power z. So this implies z is nothing but log x. Now, how you can find the value of the dy? This is nothing but my y dash, because our target is to find the y dash, y double dash. So I can start from here. Since I can write this quantity also as of this. So what is the value of the dz by dx? You can easily find the value of this is here value as a 1 by x. So from this, can you find the value of the x into y dash? This is nothing but my dy by dz. So you can see I have find this first pair. So therefore, now I want to find the y double dash. I can differentiate this function with respect to x. So here is the product rule, u into v. This is the first and so on. And again, what is that? If you again differentiate this with respect to x, this value will be like here. Now I can write this function again of this and of here. This value is again as my 1 by x, and this quantity is nothing but my second derivative. Now I can multiply this x on both sides, you will get here. This quantity I need as a here. I can substitute the value of the dxy dash is dy by dx here and can get the value of this. I can substitute this value and this value in the given differential equation. We will get the expression as of here. So you can see p, q are my constants. So this is my constant coefficients. Once it's a constant coefficient, how you can find the solution is you can solve this with the help of y complementary solutions and the y particular integral. How you can find the complementary solution is this is nothing but by y1 plus y2, which is the part of the homogeneous equations are there. And ypi is nothing but my particular solutions, which can be obtained by either of the methods, that is either by operator methods, method of undetermined, or the variation. We will see that. So let's discuss the four examples in this video. We will see here. Again, you can see firstly this is x square, this is y double dash, x, y dash. So it means this is my Cauchy-Euler are there. So once it's a Cauchy-Euler, you have to take this form. So this quantity, what is that? This quantity is nothing but, how you can remember that? This quantity is simply replaced into this here. If it is a second, then you can write simply as of this value. Similarly, how you can write this value is there? Since it's a first order derivative, so you can simply write this value as of here. So you can substitute this value in the given equations, you will get this expression. So after that, you will what is that? This is here. Or you can also use the shortcut tricks as there. This equation will convert it into this value p minus 1 of y dash plus q of y is 0. What is the p is my 5. So 5 minus 1 is 4. You can see that. Now once it's a constant coefficient, so this you can see the r right hand side is 0. So there is no particular solution. I can find the auxiliary equation, that is the m square, where m is nothing but d by dz. So can you find the root of this equation? This is nothing but my here. Since it both are the real roots, so what is the equation of this? This is nothing but e raised power minus of 2 plus of this of into z plus c2 of minus of this. So where c1 and c2 are arbitrary constant. So I can express this value in terms of the x. So x is my e raised power z. So I can write this value of, what is that? This is nothing but x raised power minus 2 plus of this, and so on. So I can write z as a log of this. So this power can be taken as upstairs. So we will get the expression as here is the required solution. Look at the second example. Again, there is a coefficient of the, here is 3. So again, this Euler equation. So we can multiply, we can take this equation. We can simply use x square of y double dash is nothing but the d square by this. We can substitute here. We will get the expression as of 3 of this. If you want to use this as of like this, p minus 1 of y dash plus q of y, then make sure that the coefficient must be 1. But here is not with us, so firstly you have to divide by 3. Anyhow, you can simply use these techniques are there. Now this is a constant coefficient. You can start with the auxiliary equation of this. Can you find the value of the m from here? You can easily find. Now it's a complex roots. So remember that whenever there is the complex roots are here, so then your complementary solution will be e raised power alpha x c1 cos of beta plus c2 sine of beta of x. Now here this is a function with respect to the z. So instead of the x, it is my z. So you can see this is my alpha is my minus half. This is here. Now you can substitute the value of the z in this equation where c1 and c2 are arbitrary constant. So this is the right answer. Or you can also simplify this part also. What is that? This is nothing but x raised power half is there. Look at the another example. Now again this is the Zender equation, but the rule we have to use the same. So since this is again the Cauchy form, or you can say this is the Zender equation. So instead of the x, I can take as a 2x minus 3 is nothing but e raised power z. Now you can see it is a, this is there. You can see this is the pair of this and so on. So now you can write this value as of same. This is nothing but my, now instead of this, you can say ax plus b of n. If this is a term, then if I say this is the square, then it will be the a square of d square y by dz square minus of dy by dz. So remember that in the last question we have seen here, this can be written directly as of this. Why? Because the coefficient of the z is my 1, but here the coefficient is my 2. So you can take 2 as a common, that should be again as a 4 here. Again, you can take the coefficient of the x as a 1, so it will be 2 as outside, so it will be 2 raised to power 1. So you can substitute both the values in the given equations, you will get as of here. Remember that this time it can't be written as a p minus 1 of there, because it is coefficients are not same. Now it's a constant coefficient. Now equation will be like here. You can solve them with the help of this. Equations are my this. So what is that? This is my c1 of there. You can substitute the value of the z in this form. You will get the expression as of here. Look at the one more example. This is the last example we have seen. Again, this is a x square of y double dash. Again, this is the Cauchy-Euler equations. So we can solve them by using x is e raised to power z. So what is that? You can substitute this value is nothing but my d square y by dz square minus of dy by dz. Or else if you want to use the shortcut, you can see this is nothing p minus 1. The coefficient is 1. So it is p minus 1 is, that is here, plus of y is nothing but 3. You can see here the right hand side is a non-zero. While all the previous example we have the right hand side is 0. You can see if you want to use the shortcut tricks, this is p minus y. So what is the p in this case is? P is my 2, so 2 minus 1 is 1. Now there are the right hand side is a non-zero. So it means our solution is my y complementary solutions and y particular solution. Firstly, we will try to solve the complementary integrals by taking only for the homogeneous part. And we will get this as a m square plus m plus 1 is 0, where m is nothing but d by dz. You can find the roots as of this. Again, this is the complex roots which is of form this. So your roots are here c1 cos of beta z plus C2 sine of beta z. We can substitute the value of alpha and beta here, we will get this. I can substitute the value of the z from here, you will get this expression. This is a part of this. Now how you can find this y of pi, that is related to this right hand side 3. So this is, you can use either as operator method, either you can use as a method of the undetermined coefficients, or either you can use as a variation of the parameter. So in this lecture we will see how you can use them as a operator method. What is operator method is, you can take as a 3 divided by what is the coefficient is capital D square plus of D plus 1, or you can write as a like this m square plus 1 plus 1, where m is nothing but my of this. This is the capital D is nothing but my operator, that is a d by d of z. Now you can write this, what is that, this is the constant coefficient, so you can write this in the form of the exponential 0. So whatever the term present here, you can take d as of this. In journal, if it is ax, you can substitute d as a. So since this is a 0, you can substitute 0 as here, you will get the expression of this as a answer. Now once yp is 3, yc I will already compute, you can substitute the value here, you will get the complete solution as of this, where c1 and c2 are my arbitrary constants. We will see in our next class how you can find this. In this class we will see how you can solve the operator method. We will see how you can solve this method of the undetermined coefficient for finding this particular integral in our next class. Till then, you can simply follow this link for finding the various other videos related to this differential calculus. Till then, best of luck students, happy learning.